Okay, so good evening everyone. Afternoon, okay? Alright, so today will be the last topic, okay, which is the ANOVA. Okay, so next week you have a Christmas break, right? Okay, 1 week. Okay, so let us finish this one first before I give you the tips for the final and also the submission date for the case study. Okay, alright, so today's topic is the ANOVA. Okay, ANOVA is the analysis of variance. Okay, this one is a topic under the statistical inference. Okay, under the topics of the statistical inference. Okay, all right. So basically, we have the t-test, one sample t-test, one sample, two sample t-test. Okay, and then also we have a pair t-test and so on. And then ANOVA is a part of the method under the t-test also. They are similar. We did the same statistical inference, right? So what is the function and what is the method that we use for the ANOVA? The first, one-way ANOVA. We do have the types of ANOVA. We have one-way ANOVA, we have two-way ANOVA, and then we have also the MANOVA. Okay, so one-way ANOVA is one-way ANOVA has just one independent variables. Okay, for example, like the differences in corona, okay, cases can be assessed by the country, and a country can have 2 or 20 or more different categories to compare. Okay, so the different cases in corona can be assessed from the country. Okay, so the country will be the independent variables. Okay, but then the country can have 2 or 20 or more than 20 of the categories to compare. All right, so we also have two types of ANOVA, but then for today we will cover only for the one-way ANOVA, the calculation and also the theoretical part. Okay, so for the two-way ANOVA is also called as a factorial ANOVA. Okay, it's also called as a factorial ANOVA. All right, so under the factorial ANOVA we refer to the ANOVA that use two independent variables, but we always consider that only one dependent variables. Okay, 2 or more independent variables. Okay, all right, so expanding the example above, okay, a two-way ANOVA can examine the difference in corona cases. Okay, this one is the dependent variable by the age group and the gender. Okay, so we have the first one is age group, the first independent variables, and then we have the second independent variable, which is the gender. Okay, all right, so the two-way ANOVA can be used to examine the interaction. Okay, when we have the two-way, so we should have the interaction between these two independent variables. So they will measure the independent variables. Okay, all right, so this one interaction indicate that the difference are not uniform across all category of the independent variables. Okay, all right, so we also have the n-way ANOVA. Okay, so you can use more than 2 independent variables. Okay, and this one we call it as a n-way ANOVA. And the last one we also have the MANOVA. MANOVA is when you consider 2 or more dependent. MANOVA when you consider 2 or more dependent variable. Normally we only see one dependent, right? But MANOVA is a 2 dependent variables. Okay, all right, so basically this is the type of the ANOVA or analysis of variance. Okay, so all right, so one-way ANOVA, what it is used for the one-way ANOVA? Okay, the one-way analysis of variance, or we call it as a ANOVA, is used to test the claim. Okay, that 3 or more population mean are equal. Okay, previously you see from the hypothesis testing that H null is equal to mu equal to whatever value, right? Okay, so this one H null will be mu1 equal to mu2 equal to mu3 and so on. Okay, because they would like to test the population mean. Okay, more than 3 or more population mean. Okay, so this is an extension of the 2 independent sample t-test. Okay, t-test we only compare 1, 2, and then for the 3 we call it as a ANOVA. Okay, so this one to test the claim that 3 or more, okay, 3 or more population means are equal. This is for the ANOVA. Okay, right? Okay, so the response variable in the variable you are comparing, okay, the factor variable is the categorical variables. okay, being used to define the groups, okay, so that we will assume that under the categorical variable we do have the K samples, okay. Alright, so the one way is because each value is classified in the exactly one way. Okay, for example, like the comparison by gender, race, political party, and also the colors. Okay, so we see the example after this, right? So ANOVA or analysis of variance is a parametric test. Okay, so if you can see the assumption of the ANOVA, they have a quite similar the assumption with the regression analysis. Okay, such as we should have the observation are obtained independent. Okay, observation are independent. The data of each factor level are normally distribution or normality independent of the cases, and also the homogeneity of the variance. Okay, and then the residual are also normally distributed. So we can see that the ANOVA is also similar assumption. Okay, having similar assumption with the regression analysis. Okay, so without you checking all this one, and then without you fulfill all the assumption under the ANOVA, you cannot proceed. Okay, same also with the regression analysis. If you don't have the normal data, so you cannot proceed. Okay, if you have multi-collinearity in your data, then you cannot proceed, because all of this they will give you the misleading result. Okay, but then normally when we deal with the real data, normality is difficult to achieve. Okay, so there is always, you found that the data is always not normal. Okay, but then according to the sum of the central limit theorem, if the data is more than 200 for the regression, then we can consider that one is normal. Okay, because when we increase the sample size, we expect that the data is normal. Okay, alright, so the assumption of the homogeneity, okay, you can check by using the leaving test. Okay, and then homogeneity of the variance by this test. Okay, leaving test. Alright, normality you can check by using the QQ plot, Shapiro-Wilk test, Kolmogorov-Smirnov test. Okay, but then for the normality, I always encourage you to use the Shapiro-Wilk test, because this one is based on the numerical result. Okay, as compared to you use the QQ plot. QQ plot is a graphical. So graphical is based on the observation. Probably the observer number 1 can say that this one is normal. Observer number 2 can say that this one is not normal. So this is always as an argument between them. Okay, so but if you use the Shapiro-Wilk test, it fits the decision, because that one is from the numerical. Okay, alright. Okay, so this one is the hypothesis testing for the ANOVA, one-way ANOVA. So basically we do have this one. H null is equal to mu1 is equal to mu2 equal to mu3, and then until the mu k. Okay, because we don't know how many population group or population mean we would like to compare. Okay, so basically 3. Okay, basically 3, but then if you have more, then you can write like this. Okay, alright, so the alternative hypothesis is that at least, okay, at least one means is different, but then we don't know which one. Okay, but then at least one mean is different. Okay, and then they have a significant. Okay, so what is some of the example, you can read on your own. Okay, alright, so okay, this one we go with the example. Okay, we go with the example. The statistic classroom is divided into the 3 rows. Okay, front, middle, and also the back. Okay, alright, so the instructor noticed that the further the student veer from him, okay, the more likely they veer to miss this class. Okay, and use an instant messenger during the class. Okay, he wanted to see if the student further away did worse on the exam. Okay, this one is just study and then example, illustration only. Okay, so the ANOVA does not test. Okay, the ANOVA does not test one mean is less than another. Okay, but then they want to test either that one is equal or at least one is different. We don't know which one is different. Okay, as long as you get the different, so that will be the ANOVA. Okay, so basically the H null is equal to mu for the front row. This one is the middle row. Okay, and then this one is back. Okay, so mu1, mu2, mu3, because we only have 3 categorical class. Okay, 3 categorical class. Okay, but then we also have the 1 factor or 1 independent variables. 1 independent variable with the 3 categorical classes. Okay, so they take a random sample. Okay, random sample of student in each row was taken, and then this one is the exam score, the marks of your test. Okay, so front row you get this one, okay, and then the middle you get this one, the value, okay, and the back is you get this one. Okay, but all of these three, the number of sample taken are not equal. Okay, you see that this one is not equal, front is not equal to the middle, and the middle is not equal to the back. Okay, so all of this has a different number of sample. Okay, all right, so you can summarize your data. Okay, you can summarize based on the sample size. Okay, the first row, okay, the first row sample size 7, 9, and also 8. Okay, and then you can calculate the mean. How to calculate the mean for this one? You total all divided by 7. You total all divided by the number of sample. You total all divided by the number of sample. Okay, so the total divided by 7, the total divided by 9, the total divided by 8. Okay, so then you get the mean of each categorical, or the mean for this front, middle, and also the back. Okay, and the standard deviation and also the variance. Okay, standard deviation and also the variance. Okay. Alright, so the variation, okay, because of one-way ANOVA, we always exist the variation. Same like you are doing the regression. Okay, so how you calculate the variation? How you calculate the performance of your regression based on the performance of the variation in your regression by using the R-square, right? Okay, so for this one, we also have the variation. Okay, variation is the sum of the square of the division between a value and the mean of the value. Okay, alright, so the sum of square is abbreviated by the SS, sum square. Okay, sum square, short form is SS, and often followed by the variable in the parentheses. Okay, so for example, we have the SSB, okay, and then SSW. So we know what is SSB, what is SSW. Okay, so why we have the variation in our ANOVA model? Why we have the variation? Because the first one, there is some variation in the data. This is called the total variation because all the values are not identical. Okay, because all the observation in each of the categorical class are not identical, therefore they might have the variation. Okay, so we have the total variation of a model. Okay, so how we know that the total variation? We have the SS total. Okay, and then we have SSB, SSW. Okay, SSB, and then we also have the SSW. Alright, so, okay, so this one, are all the sample means are identical? No, right, because we can check from this summary of the statistic, okay, the sample mean are not identical. Okay, so when the sample mean are not identical, so there will be called the variation between the group. Okay, variation between the group and then denoted by the SSB. Okay, SSB. The variation between the group. What is the main factor for this one? Because not all the sample means are equal or identical. Okay, so they will produce the SSB. Okay, so we look at the SSW. Okay, the SSW is called as a within group. Just now we have the between group. This one, the variation within group. Okay, so what is happened? Because each of the value within each group are identical, not identical. So that is why the variation is arise from this group variation. Okay, so that we call it as a SSW, within and also the between. So we have the SSB, and also we also have the SSW, the variation between this and this. Okay, so these two variations will produce this total. Okay. Alright, so this one, there are two sources of variation, SSB, and also we have the SSW. Okay. Alright, so we need to complete the table for the variation. Okay, so we have the sources of variation. The first one is we have the between. The second one of the sources variable is a within. Okay, and then we have the total sum square error. Okay. Alright, so for this one, we need to calculate the grand mean. Okay, so how are we going to calculate the grand mean? The grand mean is the average of all. Okay, value when the factor is a ignore. Okay, so the grand mean will be x bar bar, the x double bar. So this one you need to have the n x bar 1 plus n2 x bar 2 plus n 3 x bar 3 divided by n1 plus n2 plus n3. Okay, x bar bar. Okay, so what is x bar bar here? X double bar here means that you need to multiply the number of n, the number of sample from the first categorical, and then x bar 1. Okay, so this one is x bar 1 is equal to front. This one is the sample of the middle. This one is the x bar for the middle, and then this one is the last. Okay, the sample of the back. Okay, and then x bar for the back. Okay, so you divide by the number of sample. Okay, so you get this one. Okay, you get the value 7 multiplied by 75.71. Okay, all this value you can get from here. Okay, this is all the value that you get. Okay, from the summary of statistics for this ANOVA. Okay, alright, so you get all this value. The x bar bar is equal to 65.08. Okay, so x bar bar or x double bar here is important, same like the frequency distribution table, right? Okay, because if you need to find the variation, you need to do, or you need to perform the value of the mean first. Okay, before you proceed with the standard deviation and also the variance. Okay, alright, so you get 65.08. Okay, this one is for the grand mean. Okay, alright, so the difference between this group variation, the formula will be SSB is equal to summation of Ni, okay, x bar minus x bar bar. Okay, alright, so there will be, okay, N1 x bar 1 minus x bar bar plus with the N2 x2 bar minus x bar bar square, and so on. X double bar. Okay. Alright, so the rest until the last, because the value of the summation here. Summation means that you need to find the total. Okay, so SSB, there will be a derivation here. Okay, SSB will be derived like this. Okay. Alright, so how to get the SSB? Sum square of between. Okay, 75.71 minus 65.08, and then you need to square. Plus with the 9, 67.11 minus with the grand mean. Okay, so how to get 67.11? From the summary table here. Okay, from this table and also from this table. So you will get the sum square between. What is the value of the sum square between? You get the value is a 1902. Why they consider this 1902? But if you do round the intermediate step, then it does, okay? Alright, it's okay, because they want to show the result similar with the Minitab. Minitab is one of the statistical programming, not statistical programming, statistical software. Okay, so that's okay. So 1900 you get for the SSB. Okay, alright, okay, so this one, you get already the sum square of the between. Later you need to find the sum square of the within. Sum square within variation. So, how are you going to get this one? Okay, this is the formula of the sum square within. Okay, so sum square within is equal to degree of freedom multiplied by, what is this S? Standard deviation or sigma? Variance, right? Okay, variance. So you get this one. SSW will be degree of freedom. Degree of freedom, sample size is 7, so degree of freedom will be 6. Degree of freedom n minus 1. Okay, df is equal to n minus 1. Okay, degree of freedom is a n minus 1. Okay, so you will get 6 divided by 6, and then you multiply by the variance. Okay, 6 multiplied by the variance plus 9 minus 1 multiplied by the variance. Okay, and then 7. 8 minus 1, then you multiply by 80.29. So the sum square of the within you will get 3386. Okay, so you get all this. Okay, so sum square of the between, yes. Yeah, because they want to, because that one, they calculate with the manual calculation, this one, and also they calculate with the Minitab. Okay, Minitab is the statistical, what we call statistical programming lah. Okay, maybe some of the they round off in the program, they round off in the software. Okay, alright. So, but then if you answer, you just follow the data that you have. Okay, no need to round it off to the 1902. Okay. Alright, so you get all this, sum square of the between and then sum square of within, so you get 5288. Okay, so this is the total variation. Okay, how to get the degree of freedom? N minus 1. Okay, N minus 1. How to get the mean square? Sum square divided by degree of freedom. Okay, and then until you get the F, and you get the critical value. Okay. So the degree of freedom will be, okay, degree of freedom, there will be 3 groups, right? So degree of freedom for the between, you have a 2. Why 2? Because altogether we have 3 categorical class. Okay, so minus 1 you get 2. Okay, we have a front, we have the middle, and also we have the back. Okay, so 3 minus 1 you get 2. Okay, and then the sample size are 7, 9, 8. Okay, so degree of freedom of the W will be 6 plus 8 plus 7, you get 21. So 21 plus with the 2, you get 23. Okay? Alright, so you get the degree of freedom there. Okay, and the mean square. Mean square will be the value is like this. Mean square of between SSB divided by K minus 1. And then MSW. Okay, mean square of within, you get the SSW N minus K. Okay, and then MST, mean square total, is equal to SST divided by N minus 1. Okay, N minus 1 is all observation among all the 3 categorical classes. Okay, alright, so you get all this one. The mean square for the between, mean square for the within, and then the mean square for the total. Okay, alright, so all of these you get this value. Okay, 1902 divided by 2, 3386 divided by 21, okay, and then 5288 divided by 23. So you get the mean square. Okay, because after you get the mean square, then you need to calculate for the F value. Okay, F value. Okay, so F will be the MSB divided by MSW. So from one column to another column, you have the relation. Correlation is very high. Okay, so if you make mistake in the calculation here, so you make mistake for overall result here. Okay, alright, so basically the F will be MSB divided by MSW, so F will be 5.9. Okay, F will be 5.9. Okay, so how to get the critical value? Okay, from F equal to 5.9 and then get the critical value. How to get the critical value? From the F table. Okay, ANOVA is related with the F table. Normal distribution related with the Z table. Okay, F 0.05 is equal to alpha. So this one will be the first variation and this one is the second variation. Okay, so F will be, F is equal to alpha degree freedom 1, degree freedom 2. Okay, SSB and also the SSW because we only have the 2 variation in our ANOVA. So you get 3.47. This one is from the table. F distribution table, you get 3.47. Okay, 3.47. So the critical value will be 3.47, right? Okay, so what is the F here? F is equal to 5.9. Okay. So, based on these 2 values, should you reject or fail to reject? Reject or not? We reject the H null, right? Okay, because the critical value is 3.47, which is less than the F calculate this one, so we reject the H null is equal to hypothesis, right? Okay, so 3.47 and your F will be here. Let's say 3.47 is the critical region, a critical value, and then this one is the rejection region. So your value of F is a 5.9. So I fall under the rejection region. So you reject the H null. Okay. Alright. So this one we can conclude that the null hypothesis is that the mean of the 3 rows in class were the same. Okay. But if we reject, so at least one row has a different mean. Okay. Alright. Okay, so based on the conclusion, same like the hypothesis testing, there is enough evidence to support the claim that there is a difference in the mean score of the front, median, and also the back row in class. Okay, all right. So if tomorrow we will do the R. Okay, for the one sample t-test, two sample t-test, and then pair t-test, and also the ANOVA. Okay, so when the t-test, you don't need to calculate this one. You just apply the what we call the function in R, and then they will provide you the calculation. Same like you do the regression. Okay, you don't need to calculate all of this, but then you need to know this theoretical. Okay, theory for this ANOVA. Okay, what time already? Okay, so 2 minutes break before I proceed with the final exam tips. Okay. Okay, please do the TES first for those. Please do the TES first for those who haven't done yet. Okay. Yes. All right, so class, all of you done with the TES? Okay, because I checked from the system, only half of this class only done, okay? We need another 50% to complete the TES. As we check from the system. Okay, so let's continue with the topic for the final. Okay, all right. So class, you have a final exam on 8 January, right? 8 January next year. Okay, 8 January next year. Okay, so everything related to the classroom venue for the final exam or the date of final, please refer to the campus center. Okay, because I'm not the one who decide the date and decide the venue for the final exam. Okay, all right. So, but then for the topics in the final will be the introduction to statistics, okay? And then the second one is the measure of central tendency. Okay, we also have the discrete random variables. We have also the continuous random variable, special discrete random variable, hyper, Poisson, binomial, and then sampling technique, right? Okay, and then hypothesis testing and sampling distribution. Okay, regression no, correlation no, ANOVA today also no. Okay, repeat. Okay, introduction to statistics. Okay, measure of central tendency. Okay, what else? Sampling technique, that one stratified, that one the simple random sampling and so on. Okay, the fourth one is discrete, continuous, and then discrete, continuous, special discrete random variable, okay, which is the Poisson, binomial, and also the hypergeometry, and then last one is a sampling and hypothesis testing. Okay, all right, so please do all the tutorials. Okay, please do all the tutorial, the structure is like that, okay? And then for this one, okay, ANOVA no, regression no, correlation no, okay? All right, so no R code in the final, okay? The structure is like tutorial, all the calculation. Please bring your calculator, okay? And then 10% will be the theoretical and 90% is calculation, okay? Huh? 90% calculation, 10% theoretical. Okay, all right. Don't bring your own table. Table will be provided. If there is a question related to the table, statistical table will be provided. Okay, all right. So any question, class? All right. Sorry. Formula no. No formula, but then given the table. Okay. So class, this will be the last lecture today. All right, because after this, next week you have the Christmas break, right, for 1 week. And then the week after, we already finished our syllabus, okay? We already finished, but then I will have a class on Thursday, okay? Because 1 January 2025, we have public holiday, right? So on next Wednesday, we have the public holiday, okay? So our class is only 2 January. Okay, if you have any question, I will be available on the Thursday. Okay, starting from 9 until 3. Feel free if you have any question. Okay, all right. So basically, I will upload all the materials, okay, related to the final, related to this study by today. Okay, by today or maybe by tomorrow, the updated one. Okay, all right. Okay. So Abdullah, any question? Okay. So for your case study, all right. So for your case study, you need to submit on next week, okay, 29 December. Okay, and then give me 1 week to mark your assignment, okay? Case study 29 December. Okay, before 11:59 PM. Okay, only the group leader will submit. Okay, only the group leader will submit the report. What else you need to submit? The YouTube link for the video of your report, right? So you just attach in your report. The link for your video you just attach in your report, okay? And then what else? You need to submit the R code, okay? R code also, and then also the Turnitin and similarity report, okay? 29, 2024, 11:59 PM. Okay, what you need to submit report plus link for video. Okay, R code. Okay, R code you can copy and then put in the PDF file. Okay, and then also data. And also the last one will be the similarity report. Yes. Okay, similarity report. Okay. Alright, so all these 4 items you need to submit. Data set in the CSV format. Okay. Alright, so your data set in the CSV format, okay? The pre-processed one. Okay, the pre-processed one, after you have done the pre-process. Okay, so this one you can copy the code and then put it in the PDF file. This one also you need to submit in the CSV after pre-process your data. This one will be the similarity report. Okay, so I will open the Trinity and then you can check the similarity of your report. Okay, please make sure below than 20. Okay, don't copy from others. Okay, check GPT or what. Okay, please make sure that you check the similarity report. Okay. Alright, so the submission will be on the 29 December, Sunday next week. Okay? Alright, any question, class? No, eh? Okay. Alright, so I think that's all for today, class. Okay? Take your attendance first. So we'll see you next tomorrow. Okay. Thank you, thank you. Okay. So after this, I have a photo session lah. Okay.